Hello, and welcome to our podcast on nuclear chemistry.
Firstly, what really is nuclear chemistry?
Nuclear chemistry focuses on the atom's nucleus and its particles. It examines nuclear reactions which change an element's identity by altering the nucleus, especially the number of protons.
Did you know that nuclear chemistry was first used in transportation with submarines and later with airplanes? Today, researchers are even exploring e-trucks being powered by rest stops with their own mini nuclear reactors to charge the trucks.
Really? Like Cybertrucks?
Not quite. There aren't really any trucks powered by nuclear charged batteries yet, because building nuclear generators is very costly, not to mention hundreds of them all around the country.
Oh, so our technology isn't quite there yet to be able to build these everywhere.
Exactly. But hopefully in the near future, we'll see more of these nuclear powered trucks pop up.
Earlier, you also talked about submarines. What is the deal with those?
Ah, yes. We're starting to see some nuclear fission powered submarines popping up.
So these submarines work by using enriched uranium fuel. When uranium-235 atoms split, they release heat, which is used to produce steam. The steam is then redirected to turbines, and the turbines spin, generating electricity. The system then recycles the water so the process can keep running efficiently over and over again. Just in case you were wondering, the enriched uranium used in submarines is only enriched to about 50%, so the reaction doesn't get out of control.
You got it exactly right. How did you know that?
Let's just say I pay really close attention to Mr. Diosomito's class.
He must be an incredible teacher.
But with every good idea, there's always pros and cons. What do you think some of the pros are?
They can run for decades without refueling, only needing to dock for food and water. They're also much stealthier since they don't have to resurface for air like other vessels. And on top of that, they don't produce greenhouse gases, making them cleaner than even fossil fuel systems.
Really? That's crazy. But did you know the cons?
No, what are the cons?
They're very expensive to build and decommission, and even with the safety measures, there's always some risk when working with radiation. Plus, disposing of the radioactive wastes is dangerous, costly, and can take many decades.
Wow, that is really, really bad. I can see why the practicality of these nuclear fission powered submarines aren't quite there yet.
You're exactly right. That's the main issue with these advanced submarines.
That makes a lot of sense. There has to be a lot of safety precautions for advanced vehicles like that.
You're absolutely right. The reactor is built with layers of shielding. The first is a covering called a vessel, which is made of a heavy metal alloy that traps most of the radiation and heat.
And then there's probably a second barrier with lead and water tanks below, plus plastic shielding above. These block stray neutrons and gamma rays from escaping.
Exactly. There are also strict rules to keep the crew safe. No one can enter the reactor room while it is running. Engineers wear radiation monitors to make sure they don't exceed healthy limits, and shifts are carefully scheduled and planned to reduce exposure to these dangerous radiation. And that wraps up our discussion on nuclear power and transportation.
We explored everything from submarines to the future possibilities of nuclear-powered trucks, along with the pros, cons, and safety measures that make it all possible.
Even though some of these technologies are still in the research phase, it's exciting to see how nuclear chemistry could shape the future of transportation.
Exactly, and it's important to remember that with every innovation comes careful planning and safety consideration.
Thanks for joining us today. We hope you learned something new and maybe even sparked your curiosity about the power of the atom.
Remember to stay curious.
And with that, don't forget to stay safe.